So the last concept of magnetic effects is torque produced in this current carrying coil when it is placed in a magnetic field. Are you able to understand? See, for example, if this is the direction of B dash, and if I place a current carrying conductor, then it will experience a force in which direction? My L dash cross B dash. This is the direction in which this wire will experience force, no? L dash cross B dash, perpendicular and out of the board. Now what I am doing is, instead of taking a single wire, I am making into a loop. So loop can be of any shape. I have taken a square or a rectangle shape. It can be of any shape, circular shape, rhombus, anything. So for calculation purpose, I have taken this one into a rectangularly shaped loop. So where length of the loop is A and breadth of the loop is B. Okay, ma? And let us name this loop A, B, C, D. Now I want to calculate what will be the net torque. Torque means what? Effect of rotation. Net torque produced on this wire or loop because of the magnetic field and the current passing in the loop. Are you able to understand? No? We know that every current carrying produces magnetic field. No? Current carrying conductor produces magnetic field. There is already some external magnetic field. So both magnetic fields, they will interact with each other. And this coil will experience some force. Now first of all, can you say this side AB, AD, no? AD. It will experience force in which direction? Okay, ma? See, I will explain you the direction of coil. See, ma. So consider this is the magnetic field direction. Magnetic field is like this. Coil is like this. Are you able to see this? Okay, ma? So this is the direction of magnetic field. This coil is arranged like this. So this much angle it is making, a small angle of theta. Are you able to understand? Now which side we are discussing? First of all, side DA. It means this side. This side. Okay? So now can you say on this side, force experienced because of magnetic field will be in which direction? Perpendicular and? Directions are very, very, very important. Directions meeku vaadadam raakapote. Okay? Em cheyalamma? Anybody? Use change formula. Force experienced by current carrying conductor, what is the formula? F I is equals to L dash cross B dash. This is the formula. Clear, Nama? This is the direction of what you call, this is the direction of length, no? Length should be in the direction of current. I will explain you with the help of two vectors. Okay, ma? So, this is the direction of magnetic field. Okay? And this conductor, it is arranged like this. Topmost conductor, this one, DA. It is arranged like this. Are you able to understand? This is the arrangement. So this is the magnetic field. Magnetic field is in which direction? In this direction. See the direction. This is the direction of B dash. And conductor is like this. So place your right hand on L dash. Huh? B dash is here, no? Rotate towards B dash. What is the direction of thumb? Upwards. So that is the direction of force. So this is F1. Okay. Now if you see this opposite wire BC, angle is same, strength of current is same, strength of field is same, current has reversed the direction, no? Here current is in this direction, here current is in opposite direction. So force will be in which direction? Force will be downwards. So this is F2. Okay. Can I say F1 and F2, they will get cancelled with each other? That's it. So therefore, F1 and F2 cancels, or they will balance each other. Now you take side CD. CD. Now can you say what is the direction of force on CD? Huh? Perpendicular and inside the board. L dash. Direction of current. B dash. Thumb is in which direction? Thumb is perpendicular and inside the board. So this is the direction of F3. Okay, ma? So I cannot draw inside, no? So I am drawing like this. It is perpendicular and inside. Perpendicular and inside the board. Okay. Now this is exactly opposite direction of current, no? So it will experience force in which direction? It should experience force in this direction. So this is F4. So here what is the direction of current? Force perpendicular and out of board. Okay, ma? Are you able to understand? Forces first we have understood. Now see what happens. So this is the coil. This is the coil. So F1 and F2. These two forces, they are getting cancelled with each other. F1 and F2. So they are not responsible for rotation. Clear? Where is F3? F3 is here. It is pulling the loop inwards. F4 is here. It is also pulling the loop outwards. So therefore this coil starts rotation. Are you able to understand? No? This one is pulling the loop inside. This one is pulling the loop outwards. So therefore net torque is produced. That's all very simple. Are you able to understand? No? So therefore what I say, therefore F3 and F4 are equal and opposite. Equal and opposite, and so produce a torque. Produce a torque. Are you able to understand? So because they are producing some torque, this coil starts rotation. That is the principle of our fan. Okay, ma? If you open the fan, inside the fan you will find this armature. Copper windings untai chusnara. Those copper windings are nothing but this armature. Okay, ma? And around the copper windings there will be electromagnets. Electromagnetism will be produced. So when you pass current in this armature, torque is produced and fan starts rotation. Very simple. Working of a motor principle. Are you able to understand? Ma? Now see. So therefore, how can I calculate torque? R into F I cannot use here because one force is not acting, no, two forces are acting. So here what I will do is, one more equation of torque is either force multiplied by length of arm. Length of arm. Length of either force you can call it as couple. Here a couple is acting, no? To equal and opposite forces is called a couple. So when couple is present, by this method I can calculate torque. Either force means any one force multiplied by length of the arm. Okay. Now let us see how we can calculate length of the arm. See ma'am, listen very carefully. So if I look from here, pine nunchi chuste, how it appears to me. So it appears as if this is B dash and this is the conductor. This is what I see, no? If I see from the top, then this is B dash and this is the conductor. And what is the length of the conductor? B. So this B I will split into two components. So if this is theta, this is also theta, this is B cos theta, and this is B sin theta. Okay. So forces are acting at these two ends only, no? Here one force is inside, here one force is outside. So what is the perpendicular distance between the forces? Perpendicular distance between the forces is B cos theta. That is my force, that is my length of the arm. Are you able to understand now? What is meant by length of the arm? Perpendicular distance between two forces. Are you able to understand? So therefore, first make a note up to here. Okay, ma? Now see. So therefore, now let us do the calculation. Torque is how much? Torque is equals to either force. See ma, on each conductor, F is equal to ILB will be the force, no? So write down ILB. And what is the length of this conductor? Length is L only I have taken. I have taken L only, no? So ILB. Multiplied by, and what is the length of the arm? Length of the arm is B cos theta. B cos theta. Perpendicular distance between two forces. Okay. So multiplied by B cos theta. Okay. So L into B is nothing but area, no? L into B is nothing but area of this armature or area of this coil. So substitute. So torque is equals to IAB cos theta. So this is one equation to calculate torque acting on this conductor. Are you able to understand? No? But here you should be very careful what is meant by theta. Theta is the angle between magnetic field and side of the conductor. Side of the conductor. But generally, how we draw area vector? For example, if this is a cylinder, area vector is outward drawn normal, no? Area vector is outward drawn normal. Do you remember? Similarly, for this coil, area vector will be outward drawn normal, no? This is A dash, area of this coil. Are you able to understand? See, if this is the coil, how can I draw area of this coil? This is how I draw the area of this coil, no? Outward drawn normal. That is A dash. Okay? So therefore, if this angle is theta, this angle is 90 minus theta, no? Remaining angle. If this angle is theta, remaining angle should be how much? 90 minus theta. So therefore, torque, how can I calculate? Torque can be calculated as IAB cos 90 minus theta. If I take angle with respect to A dash. Are you able to understand, ma? So therefore, cos 90 minus theta is how much? Sin theta. Okay, so this is one more equation to calculate torque. But cos we will use in which condition? Sin we will use in which condition? Cos we will use when angle is taken between length of the conductor and B dash. Sin we use when angle is taken between magnetic field and area of the conductor. Area means area vector of the conductor. Generally we don't use this formula, generally we use this formula. Angle between A dash and B dash. What is theta here? When we use this formula, here theta is nothing but angle between area vector and magnetic field. Understood, no? Okay, now see. So, see one more equation. IAB, or I will write one case, ma. This one completed, no? So, see. So, I got equation up to where? I got equation up to torque is equals to IAB sin theta. Clear, no? So, case is that if n number of turns are present, if n turns are present, okay, ma? See, ma, in this fan, is there only one winding? Oka winding untadi, thousands of winding will be present. So, if many number of turns are present, then what is the torque? NIAB sin theta. This is the total torque produced. Clear? And this ratio NIA, it is called magnetic moment produced. What is NIA, ma? Magnetic moment produced in the coil. It is called NIA. Number of turns, strength of current, area of the coil. So torque can be written as MB sin theta also. M is nothing but magnetic moment. Okay, ma? And this is just like cross product, you know. And what is the equation of cross product? Tau dash is equals to M dash cross B dash. So you can represent a torque in terms of cross product also. Are you able to understand, ma? So this is the net torque which is produced in the coil. So because of this torque, coil starts rotation. So what is the formula you have to remember? Torque is equals to IAB sin theta. And one more equation is MB sin theta, where M is nothing but NIA, which is nothing but magnetic moment. And in cross product form, you can write like this, M dash cross B dash. Fine? That's it. So that completes our topic called magnetic effects of current.